This video is meant to introduce the concept of radians. You can measure an angle in degrees, but you can also measure an angle in radians. And the definition of a radian is also defined in terms of a triangle. 1 radian represents an angle where the arc length, and the arc length is this red portion right here, that arc length is equal to the radius of the circle. Radians are defined as the ratio between the arc length and the radius of the circle. And since you have radians as a ratio, radians are unitless. This is given by the following formula. So this formula right here is the general formula for the technical definition of radians. Radian is the ratio of arc length over radius. We can use this formula in several examples here to find any one of these variables here, whether it's the radian measure, the arc length, or the radius. So you can take a second here and try this out for yourself. Use this formula or rearrange this formula to solve for the missing variable. Hopefully you've had a chance to try this out, and the answers for each of these examples are given below here in red. Note that the arc lengths and the radius have the units provided in the question, which is to say centimeters, but radians, as we indicated before, is a unitless measure of an angle. We can now look at the relationship between degrees and radians. If you look at the circle drawn to the left of over here, if we had one angle undergoing a full revolution, that is to say this entire angle of the circle, you might recall that the entire angle of a circle is 360 degrees. So let's investigate using the arc length and radius. What would the arc length be equal to? So what is the arc length of a full circle? So created by one full revolution. Well, the arc length there would be equal to the circumference. And so we can use the formula for circumference, which is 2 pi r. Now, using the formula for radians, we know that radian is equal to theta is a over r. We can substitute a using circumference in this case. Theta is equal to 2 pi r over r, and we note that the r's will cancel to 1. So theta is equal to 2 pi. Going back to the circle, we know that a full revolution of a circle is 360 degrees. We also have derived that the full revolution of a circle in radians is 2 pi. So our final conclusion can be that a full revolution is 360 degrees, measured in degrees, and a full revolution is 2 pi, measured in radians. So therefore, 360 degrees is equal to 2 pi, and alternatively, 180 degrees is equal to pi. So that right there represents the relationship between radians and degrees. Using this relationship right here, 180 degrees is equal to pi radians, we can come up with expressions for various common degrees that we see when doing trigonometry. So pi over 6 radians is 30 degrees, pi over 4 radians is 45 degrees, pi over 3 radians, 60 degrees, and pi over 2 radians is equal to 90 degrees. Alternatively, if we want to convert degrees to radians, we can multiply by pi over 180 degrees, or if we want to convert from radians to degrees, we can multiply by 180 degrees over pi. If we want to convert the following, so 4 pi over 3 radians to degrees, again, if we want to go from radians to degrees, we could multiply by 180 over pi in our calculator, But alternatively, we can also think that 4 pi over 3 is the same thing as saying 4 times pi over 3. And since we know that pi over 3 represents 60 degrees, well, 4 60 degrees is equal to 240 degrees. The same thing applies over here. 150 degrees converted to radians, we can multiply by pi over 180. Alternatively, we can also think, well, 150 degrees is the same thing as saying 5 times 30 degrees. So 5 times pi over 6, or 5 pi over 6.